My name is Tim Zanaris, and the topic of my project for our fuel science chemistry class is hydrogen gas, the future in zero-emission engines. Hydrogen fuel cells are able to convert hydrogen-rich fuel into electricity, and as long as a fuel source is provided, these fuel cells will continue to work. A fuel cell is composed of an anode, a cathode, and an electrolyte membrane, and works by passing hydrogen through the anode and oxygen through the cathode. First, the hydrogen molecules split up into proteins and electrons at the anode. The protons then pass through the electrolyte membrane, while the electrons generate an electric current and heat as they go through a circuit. At the cathode, the protons, electrons, and oxygen combine to produce water molecules. Fuel cells can actually be stacked for larger systems, which makes them highly versatile as well. They can be as small as portable phone battery chargers and as large as a massive installation that can provide electricity to the utility grid. Through a process called steam methane reformation, about 95% of the United States hydrogen gas comes from natural gas. Since almost all of the hydrogen gas in the country comes from natural gas, the hydrogen can be considered a fossil fuel. In steam methane reforming, methane reacts in an endothermic process with steam under 3 to 25 bar pressure in the presence of a catalyst to produce hydrogen, carbon monoxide, and a very small amount of carbon dioxide. Next, what is known as the water-gas shift reaction occurs. The carbon monoxide and steam are reacted using a catalyst to produce carbon dioxide and more hydrogen. Lastly, in a process called pressure swing adsorption, carbon dioxide and other impurities are removed from the gas stream, leaving mostly pure hydrogen. Two of the equations can be seen in the picture on the right. Fuel cell vehicles that use hydrogen gas have only one tailpipe emission: water. Unlike regular combustion engines that produce many harmful emissions, hydrogen gas offers the ability to completely eliminate any harmful gases or liquids coming out of the tailpipe. However, the manner by which hydrogen fuel is made can affect how clean hydrogen fuel cell vehicles actually are. Even when the fuel comes from one of the dirtiest sources of hydrogen, natural gas, today's fuel cell engines can cut greenhouse gas emissions by over 30% when compared with their gasoline-powered counterparts. Under California's renewable hydrogen requirements, reductions are over 50%. Many future models of these cars have even higher projected reductions as well. Also, hydrogen can be produced from sources of energy that are lower in carbon than natural gas. Electricity from solar or wind power, for example, can be used to split water into hydrogen and oxygen through a process known as electrolysis. This method increases the greenhouse reduction much faster than waiting for natural gas technologies to improve. The only problem is the availability and financial stipulations that come with using alternative energies. There are many benefits that come with using hydrogen fuel cells in place of a normal combustion engine. Some of them include zero emissions from the tailpipe, high efficiency, energy security, durability, and the ability to stack fuel cells for larger energy needs, as mentioned before. Although collecting hydrogen gas is not a perfect zero-emission process, the projections in the future suggest that we will be able to obtain hydrogen gas at a much more efficient rate. Even with less than perfect emissions from the production of hydrogen gas, hydrogen fuel cell engines are still a better route because the overall greenhouse gas emissions are lower today and will continue to become lower as technology advances. As you can see in the picture on the right-hand side, the technology also helps with space in most car designs. The need for a large combustion engine is gone, and the only downside is that the hydrogen tank is slightly larger than a gasoline tank, which is usually fairly irrelevant. Being the most abundant element on the planet, this technology could be groundbreaking in helping the world reduce its greenhouse gas emissions and also decrease the cost of transportation. Hydrogen gas can also be used for more than just fuel cell vehicles. They could even be used to provide electricity and heating to buildings, thus decreasing the demand for power that gives off greenhouse gases even more. In the end, even if hydrogen is considered a fossil fuel as it is derived from natural gas, hopefully in the future there will be more efficient methods of collecting hydrogen gas that may remove its temporary status of a fossil fuel. With all of the alternative energy options being explored today, none seem more possible and more easily implementable than hydrogen gas, especially its use in transportation vehicles in replace of today's combustion engines. Thank you for listening.